All right, last lesson for today. Again, there's a worksheet that goes with this guy, and if you need help, I will be on Tuesday at 10 a.m. for office hours. We're talking about a process that we use in the lab today called a titration, and this is the idea of neutralizing an acid or a base with the acid or base. So if I have a base, I'll neutralize it with an acid. If I have an acid, I'll neutralize it with a base. This is a really common procedure used in chemistry. This is how we test for lots of things in chemistry. It's probably one of the most common laboratory techniques. So we're going to talk about chemical equations of neutralization and how these reactions are used in acid-base titrations. And then buffered systems, we decided to cut that so we can just skip that right there. Here's the new vocab that you're going to be dealing with: neutralization reaction, titration, titrant, equivalence point, acid-base indicator, and endpoint. Remember that stoichiometry is the study of quantitative relationships between the amounts of reactants used and products formed in a chemical reaction. We base it on the law of conservation of mass. Most of the time when you're doing your stoichiometry, you're using dimensional analysis like this. We're actually going to be doing stoichiometry today, but not using that type of dimensional analysis. We're going to take a shortcut. When an acid and a base react, a neutralization reaction occurs. This reaction produces a salt and water, and it causes the acid and base to be neutralized. In other words, in most systems, the pH is going to be either raised or lowered to achieve a 7 pH. And we're going to say that the solution is no longer acidic or basic. It is now neutral. In order to do this, we need to have equal number of moles of H plus and OH minus. So once we have achieved that, then we're going to say it is now neutral. So if we have something with more H plus, it's acidic, so we would add OH minus to equal them out so that it becomes neutral. That's the idea of a titration. A salt that is formed, or the salt that is formed when an acid and base react, is produced from the cations of the base and the anion of the acid. So the cation of the base and the anion of the acid go together to form the salt. Whenever we do this and carry out a neutralization reaction or a titration, we basically end up with a salt solution. So whatever the salt that's formed, that's the solution we end up with. So we started with an acid and a base, and we ended up with a salt solution. The stoichiometry of an acid-base neutralization is the same as any other reaction. So if you're solving through it, we can look at it and we can say it takes 2 moles of acid to react with 1 mole of base. So that's the stoichiometry of the reaction. It's just looking at the molar values. A common procedure to figure out the concentration of an acid or a base is called a titration. If I were to say, well, vinegar is very acidic, it has acetic acid in it, and you were to ask, well, how acidic is it? Well, I would have to take a sample of that vinegar and carry out a titration to figure out how much acid is in there. This is what a titration looks like. You would have a sample of the unknown concentration. So this would be unknown concentration. That's what the brackets mean. And then we would use a known concentration of the opposite species. So if the species in the bottom, the unknown concentration, was an acid, we would titrate it with a base. This right here is called the titrant. Okay, that's what we are titrating with. So that's our titrant. So what we've got here in this particular example, it looks like we have some methanoic acid in the bottom. And so it says the flask contains 25 milliliters of methanoic acid. Right here in the middle, he's got a dropper there, or she's got a dropper, and they're dropping in an indicator, something that's going to change color. And so we'll talk about those in a minute. And they start to drop in 1 drop at a time, this titrant, over and over, and you can kind of see a little bit of a color change. once the solution changes color because of the indicator, we know that the titration is done. This is just the general procedure for a titration. The solution that you're dropping into the flask is called the titrant. When we have an equal number, when H plus equals, or the concentration of H plus equals the concentration of OH minus, then we've reached what's called the equivalence point. To calculate in a titration, we're going to use the equation M1V1 or MAVA equals MBVB. In other words, the molarity, the concentration of the H plus times its volume is going to be equal to the concentration of OH minus times its volume. And X and Y is the molar values from the balanced chemical equation. So let's try one here real quick. It says a volume of 18.28 milliliters of a standard solution with 0.1 molar NaOH. Okay, so NaOH is our base, so we can go ahead and fill in 0.1000 times the volume 18.28. Now it doesn't matter what unit your volume is in, you've got to use the same unit. All right, equals, it says methanoic acid, 25 milliliters of ethanoic acid. What was the molarity of the ethanoic acid? So we're going to say Ma times 25.00. Well, the only thing we still need is, what is this divided by? Well, NaOH plus, let's see, CHOOH. So we're going to say that it's got one H on it that's going to react, equals NaCHOO plus H2O. And so this balances out as 1 to 1. So I'm going to say 1 to 1. So when we calculate through, 18.28 times 0.1 gives me 1.828 equals Ma times 25.00. Divide both sides by 25. Ma is equal to 0.0731 molar. Okay, so that's my concentration, which is equal to the concentration of H plus. All right, so that's how those are solved. They're pretty straightforward. Go ahead and do numbers 6 through 8 on the worksheet. All right, remember, if you're having trouble with those, make sure that you show up at office hours and ask for some help. When you carry out a titration, you have to have some way to tell when your amounts are equal, when you've reached that equivalent point. However, most acids are clear, colorless solutions. Most bases are also clear, colorless solutions. And when you add two clear, colorless solutions together, you get a clear, colorless solution. So if you don't have a way to tell when they're equal, you wouldn't know when you've achieved that point. And that's what an acid-base indicator does. Most of the acid-base indicators we want are ones that change color right around this 7 mark, because for most of our equivalents, they're going to show up at 7, although it's not always the case. So as long as we know which indicator to use, a lab procedure would tell you that, a little research would help, but basically we can see like this acid-base indicator, this is all the same indicator, and it has changed 3 different colors and 3 different pHs. So this is just a chemical dye that changes color based on the pH of the solution. There's a lot of cool chemistry and how that does that. We don't have time to talk about it, but the acid-base indicators are really common. You use them in your fish tanks. You use them in pool chemicals. If you've ever tested pool chemicals and you see those color changes, that's an acid-base indicator. It's the exact same thing. When the acid-base indicator changes color, we call that the end point of the titration. And so we say that the titration has ended. It's not necessarily the equivalent point. It's just the point at which we know what the pH is. So if we know what the pH is, then we know the concentration of hydronium. We can solve for the concentration of hydroxide and vice versa. So this is just part of the lab technique. So that's the end of chapter 17. We're having a little switch up this week. We're going to do a review on Wednesday. You'll see that post Wednesday. And then on Friday, I'll be posting your chapter 17 test. And so that will be the last thing that we'll do. I hope everyone's doing well and can't wait to see you guys next year back at Riverview.